Okay, in this video we're going to continue our look at linear systems of equations and solving them with the graphing calculator. And in this specific video we're going to utilize the matrix method within our calculator to solve these. The matrix method is appropriate when you have your lines in standard form. So that means that x and y are on the same side together with a constant on the right side. And we have that situation here, so the matrix is what we will use. If you have lines in y equals, the appropriate and most efficient method would be to put them in y equals, find where the graphs cross, or find where y1 and y2 are the same in the table. And we did that on the previous video, so if you want to take a look at that again, you can in that other video. But in this one we will focus on the matrix method. Of course, if you have lines in standard form and you prefer the y equals method in your calculator, then you can rearrange the terms to get y by itself and do it that way. As the same way, you can take lines that are in y equals and put them in standard form if you decide you like the matrix method better. But I would like you to be able to do both methods so that you can, whatever you're given, you can be the most efficient with it, because of course anytime you start rearranging things algebraically you have an opportunity to make a mistake. So it's most efficient to just take what you're given and use the appropriate method. So standard form would be matrix, y equals would be utilizing y equals in your calculator, find where the graphs cross, or where y1 and y2 are the same in the table. Alright, so let's get started. The first thing and most important first step is to make sure that your equations are stacked correctly. And when I say that, I mean that if x is the first term in the first equation, you need to stack them just like this. X, then y, then the constant on the right side of the equal sign. This is incredibly important. If you don't do this correctly, you will not get the correct answer. So you have to do it this way. X, I want all my students to do it exactly like this. Stack the x's, the y's, and the constants just like this. X, then y, then the constant on the right side. That is incredibly important for matrix to work for you correctly. Alright, so now that we see we have standard form lines and we have them stacked correctly, our next step is to go in our calculator. Everything will go through this matrix menu, and that is second x to the negative 1. Second matrix right here, this key right here on your calculator. So let's go into the matrix menu. There will be several steps here, but I promise you, once you do this a few times, you'll have it down and you'll have it memorized and you won't forget it. It's a very simple process. It's just several steps. So the first thing you're going to do, second matrix again, everything goes through the matrix menu. You're going to arrow to the right to the edit key. Alright, hit enter. Notice your default setting will be a 1 by 1 matrix. You must use a 2 by 3 matrix. 2 by 3 matrix. That is incredibly important as well. You have to have a 2 by 3 matrix. 2 by 3 matrix. That means 2 rows by 3 columns, and that's what we have here. We have 2 rows, and we have 3 columns. So that's what we want to set our matrix up as, 2 by 3. So 2, enter, 3, enter. And you notice when we do that, our setup now looks exactly like what we have right here. We have 1, 2, 3 columns, 1, 2, 3 columns over here. We have 2 rows, 1, 2 rows, and we have 1, 2 rows here. Now we simply put in the coefficients in front of each term into the calculator in the correct spot. So coefficients, of course, are the numbers in front of each of these variables and then the constant. Okay, so what is in front of this x? It is a positive 2, so we can just hit enter there. We've got 2 in there. What is in front of this 1? There's no number listed, so there is an implied 1 there. So we're going to do that. And we have a 2 right here, so we'll put that in. So now we have the first one entered. 2, then 1, then 2. Here we have 2, then 1, then 2. Now we start entering the second one right here. So we have an implied 1 in front of that x. We have a negative 1 in front of that y. So negative 1 goes there. And then we have a 4 right here. Okay, let's double check our matrix. We have 2, 1, 2. We have 2, 1, 2. That checks. We have 1, negative 1, 4. We have 1, negative 1, and 4 here. So everything checks out. Next, we hit second mode to quit and get out of that screen. Now we go back into matrix. You must hit the second mode button to quit before you go back into matrix, otherwise it'll mess it up. So second matrix again. Now the next step is to go to the math menu. We've already edited our matrix and got it set up just like this. Now we go to math to tell our calculator what to do. We're going to choose the reduced row echelon form, which is option B right here. Okay, that's what we want our calculator to do to that matrix. The shortcut, let's go back in, second matrix again, you go straight to the math key. Your calculator will look like this. The shortcut is to choose option B directly, which is alpha apps. That's the shortcut, and it'll automatically put that in. You could arrow all the way down or arrow to choice B, but alpha apps is what you want to do. That's the quickest way to do it. Now we want to hit second matrix again. Again, everything goes through this matrix button. Hit enter because we are choosing matrix A that we have created. Now we can close the parentheses or not, it doesn't matter. Hit enter, and now our calculator gives us the solution. So let's drag this over and take a look at what it's really telling us here. So what our calculator has done is it's given us the solution to this matrix. And the way it has done it is in this. I'll show you exactly what this printout right here means. It means that 1x plus 0y equals 2. That's this first row right here. 1x plus 0y equals 2. Notice it's in the same order. X, then y, then constant. X, then y, then constant. So it's 1x plus 0y equals 2. The second row tells us that 0x plus 1y is equal to negative 2. So if you simplify these, the y's fall off, so you're left with 1x equals 2, which means x equals 2. Here, 0x, the x's would fall off, so you're given 1y equals negative 2, or in other words, y equals negative 2. So that means the solution to this system right here is at the point 2, negative 2. So there's your answer, 2, negative 2. That is where these two lines would cross, and that is the solution to your system. Alright, we're going to look at another example here. And before we look at another example, let's check this. We can always check this to make sure we put it in right. So what this tells us is that when we substitute a 2n for x and a negative 2n for y, it makes these two equations true. That's all it means. That's all that this is telling us. Okay? So we can check that here by substituting 2n for x and negative 2n for y. So let's do that. We have 2 times x would be 2 in this case. 2 times 2 plus y is a negative 2, so plus a negative 2, or we could just say minus 2, either way. This should equal 2. And it does. So that checks. We know we did it right. We can use this equation to check it as well. So we're going to substitute a 2n for x in this equation. So 2 minus, our y is a minus negative 2 or a plus 2. Minus and negative is the same thing as plus. And this should be 4. And it is. So we know we have done it right. This is the solution that makes these two lines equal to one another. So 2, negative 2. Alright, now to another example. Okay, so now for our next example here. We have 2x minus y equals 8 and y plus x equals 1. So they're in standard form, so we want to use matrix. Now we have to make sure they're stacked correctly. And we can see, we've got an issue here. Right now we have 2x minus y equals 8. That's in the right order. And then we have y plus x equals 1. These are not stacked correctly. We have x over y and a y above the x. We can't have this. So we need to erase this one, and we just need to rearrange it. So we're simply going to move the x in front of the y. So we're just going to rearrange these two terms. We're going to swap these out here. Okay? So we've got x plus y equals 1. And we realize that that's the exact same thing y plus x equals 1 is the same thing as x plus y equals 1. Okay, we just rearrange these terms, and that's okay to do. Okay? Alright, so now we've got it stacked correctly. Now we can start entering it into our matrix. In the previous example, we already had our 2 by 3 matrix set up, so we won't have to worry about that now. So remember, we go to Edit first to enter the matrix in correctly. We have 2 by 3 in there, so that's right. Then we enter the coefficients. So we have 2. In front of this y, we have a negative 1. Don't forget that sign, negative 1. And then here we have an 8. Okay, so we've got the first one, 2, negative 1, 8. 2, negative 1, 8. That one's right. Here we have 1, 1, and 1. So it's 1 in front of the x, 1 in front of the y, and our constant is 1. Okay, so our matrix is set up 2, negative 1, 8, 2, negative 1, 8. We have 1, 1, and 1. We have 1, 1, and 1 here. Next step, second quit. Second quit right there like that. Okay. Now, the next step was go back into matrix, second matrix over to math and alpha apps. Our reference is in there. Now we can just hit second matrix, choose option A, and close parentheses if we want, hit enter, and we have our solution right here. So the calculator, let's drag this over, it gives us this printout right here. And of course this is the key part right here. That's what we're looking for right there. Okay, so it gives us that 1, 0, 3. So that means, shortcut this, x equals 3 and y equals negative 2. So our solution is 3 comma negative 2. Alright, so that's where these two lines would cross, and that's what makes these two equations true. When x is 3, y has to be negative 2. That's what it means. And remember that the explanation of why the calculator is printing it this way, it's 1x plus 0y equals 3. Okay, that shortcuts or it simplifies to x, 1x equals 3, which is x equals 3. Okay, the second row is giving us that 0x plus 1y equals negative 2. So y equals negative 2. 1y equals negative 2, so y equals negative 2. That is the solution to that situation. Now we can check it. So we're going to substitute a 3 in for x and a negative 2 in for y. So this first equation right here would be 2 times our x is 3, so 2 times 3, minus, and our y is negative 2, so minus a negative 2, which is the same thing as adding, and that should be 8. And it is, so we know we did it right. We can also use this equation and check it again. That's fine to do. So we have x is 3 plus y is equal to negative 2, so plus and negative is the same thing as subtracting, and that should be 1. And it is, so we know that we did it correctly. Alright, so we've checked it, and we've used our matrix. Remember, the steps were enter the matrix under the second matrix menu in the edit to put this in correctly, then second mode to quit, then second matrix again, alpha apps, second matrix again, and hit enter. So those are the keystrokes. Alright, let's move on to another example here. Alright, here we are back with another example. We have it in x and y on the same side, but you see here that our y's are first. You could technically put this into matrix and it would just give you the y value first, but just to keep you from getting confused, I want you to keep this pattern the same. So I want x and y I want it to be x and then y and then the constant on the other side of the equal sign. So we just need to rearrange this a little bit. We have negative x. I'm just moving this over. I'm moving the x before the y. So we still have a negative x over here. The sign didn't change. We're just moving it over. Minus 3y. We still have a negative 3y. We still have a negative x, just like we had right here. And that equals 3. Okay, then I'm going to rearrange this. I'm just going to move the 2x in front of the y term. That's all we're doing here. So we have a 2x plus 6y equals negative 18. Okay, technically in standard form, you should have a positive x term, so we would just need to change the signs of all of these, but in your matrix it doesn't matter, so we'll just go with this. Alright, so let's clear that out. Now, we know that we have two lines in standard form. Our x's and y's and constants are stacked correctly, so we know we've got all that done. Now we go into matrix. So second matrix, over to edit, hit enter. We have a 2 by 3 matrix, so that's done for us. We need -1, -3, and 3 for this first one. -1, -3, and 3. Okay, let's check it. -1, -3, 3. -1, -3, 3. Perfect. Next one, we need 2, 6, and -18. 2, 6, -18. Check it. 2, 6, -18. Alright, so our matrix is correct. Now it's second mode to quit and get out. Now we go back into matrix. Everything goes through matrix. Second matrix, over to math. Alpha, apps. Second matrix. Enter. Enter one more time. Okay, there's our printout. So let's drag this over. Alright. So, our calculator tells us that we have this is an interesting situation. We have an issue here. Okay, so this is telling us that 1x plus 3y's equals 0. Okay, that's what the first row is telling us. Then it tells us that 0x plus 0y equals 1. Okay, this right here, this bottom part is impossible, right? Because 0 times anything plus 0 times anything is 0, not 1. So this is impossible. Therefore, this is telling us that there is no solution. Remember, when we have systems of linear equations, we can either have a single solution where the lines cross, we can have no solutions where the lines are parallel and never cross, or we can have infinite solutions where they are the exact same line. In this case, these are two parallel lines that will never cross. Therefore, they are no solution. Okay, there is no combination that will make these two lines cross. There is no single point where they cross. Your calculator is giving you the no solution right here. So this is the key. When you see 0, 0, 1 in a row of your matrix, it means no solution. So let's rearrange these lines here and just check them, and we will see that they have the same slope with different y-intercepts. And we know that that means no solution. So let's do that. So we have -x minus 3y equals 3. So let's rearrange that. Let's add the x. We get -3y equals 3 plus x. Divide by -3 on everything. And we get y equals -1 minus 1/3 x. Rearrange that and we get y equals -1/3 x. 1/3 x minus 1. Let's rearrange the other one. We have 2x plus 6y equals -18. We can prove that this is no solution. Two parallel lines. So let's subtract 2x. We get 6y equals, I'm going to go ahead and move this, put it in the right order, -2x minus 18. Divide everything by 6, divide by 6, divide by 6, and we get y equals -1/3 x minus 3. Okay, and look what we have here. This line has a slope of this line has a slope of -1/3. This line has a slope of -1/3. This one has a y-intercept of -1. This one has a y-intercept of -3. Same slope, different lines. Same slope, different y-intercepts means two lines that are parallel and they will never cross. Okay? That's very, very important for you to understand. Same slopes, different y-intercepts. The lines, they're going to look something like this on a coordinate plane. -1/3 slope going through -1, and then -1/3 slope going through the point -3, going through the y-intercept of -3. Okay? So we have proven that this is no solution. Alright, let's move on to one more example and we'll call this video done. Okay, so now for this last example. Alright, we have two lines. They are in standard form, so we immediately think matrix. They are already stacked correctly. We have x plus 4y equals 4, and we have negative 2x minus 8y equals negative 8. Okay, again, we have the situation where in standard form, to be correct, we shouldn't have a negative in front of the x term, but our matrix doesn't care, so we're just going to leave it this way. The most important part is we have x as the first term in both equations, we have y as the second term, and we have the constants on the right side of the equal sign. So they are stacked correctly. Alright, now we can start entering this into our matrix. So let's go second matrix, over to edit, hit enter for matrix A. We already have the 2 by 3 matrix set up, so we need the coefficients here are 1, 4, and then we have a constant of 4. So 1, 4, 4 is what we need here. 1, 4, and 4. Alright, next we have negative 2, negative 8, and negative 8 again. Okay, let's check our matrix. We need 1, 4, and 4. 1, 4, and 4, check. Negative 2, negative 8, negative 8. Negative 2, negative 8, negative 8. Check. So everything checks out. Now second, quit. Back in, second matrix, over to math. Alpha, apps, second matrix, enter, enter. And let's get our printout pulled over here. Alright. So here's what our matrix, our calculator is telling us. It's telling us that 1x plus 4y equals 4. Okay, already that's looking a little weird. But here's the key. This row right here. That row right there. It's telling us that 0x plus 0y equals 0. Okay, 0 times anything is 0. Plus 0 times anything, 0. 0 plus 0 is 0. Absolutely. That is always true. That is always true. So that means we have our other special case that is infinite solutions. This means when your calculator gives you this, it's infinite solutions. That means these two lines right here are exactly the same line. Those two lines are exactly the same. Okay, we can prove that quickly. We have x plus 4y equals 4. So let's get y by itself so that we can look at these two a little bit easier. So we subtract the x and we get 4y equals negative x plus 4. Divide everything by 4 and we'll end with y equals negative 1/4 x plus 1. Okay, let's look at our second line. Negative 2x minus 8y equals negative 8. Let's get x and y on the same side, so that gives us negative 8y equals 2x minus 8. We're just moving the x over. Divide everything by negative 8, and that gives us y equals negative 1/4 x plus 1. Negative 1/4 x plus 1. Alright, so look. Negative 1/4 x plus 1, negative 1/4 x plus 1. These are the same two lines. They are stacked on top of one another and therefore have an infinite number of solutions. Alright, so we've covered everything with matrix. We've had one solution. We've had the first two examples we worked had one solution. Then the third example had no solutions because the two lines were parallel with different y-intercepts, therefore they would never cross. And then this last example had infinite solutions because they were the exact same line, exact same slope, exact same y-intercept. So infinite solutions. So we've covered all of those. Hopefully this video has helped. You just have to use matrix. Just practice with it and you'll get the steps down and you'll be extremely fast and efficient as far as what keystrokes you need to hit to get your calculator to work these out for you. Alright, I hope this video has helped and I will see you in the next video. Make sure and subscribe to the YouTube channel, Mr. Howard Math.